Welcome to chemistry classes by Vijay Kumar Sethi. Class 12th chemistry. We will start unit 14, that is biomolecules, and in this video we will discuss about what are carbohydrates and classification of carbohydrates. First of all, carbohydrates. Some common examples of carbohydrates are cane sugar, glucose, starch, etc. Most of them have a general formula CxH2OY. So initially carbohydrates were considered as hydrates of carbon according to this formula. Okay. For example, glucose C6H12O6 fits into this general formula like this, where X is 6. Okay. And Y is also 6. That's why this is C6H2O6. But all the compounds which fit into this formula may not be classified as carbohydrates. For example, acetic acid. Formula is CH3COOH. This fits into this general formula like this, C2H2O2. Okay. If you write its molecule formula, you can write this is C2H4O2. Okay. And this can be write like this. But it is not a carbohydrate. Similarly, rhamnose, this is formula is C6H12O5 is a carbohydrate, but it does not fit in this definition. That's why the definition of carbohydrates is changed, and now chemically the carbohydrates may be defined as optically active polyhydroxyaldehydes or ketones, or the compounds which produce such units on hydrolysis. Clear? Once again, try to understand optically active. We have already discussed what is the meaning of optically active. Compounds which rotate the plane of plane polarized light. These are optically active compounds. Okay. And these are polyhydroxy. That is more than one OH group is present. Along with aldehyde or ketone. Okay. Or the compounds which produce such units on hydrolysis. These are carbohydrates. Carbohydrates are also called saccharides, SACCHARIDS, saccharides. Greek word saccharon means sugar. Some of the carbohydrates which are sweet in taste are also called sugars. The most common sugar used in our homes is named as sucrose, whereas the sugar present in milk is known as lactose. Okay. Now come to classification of carbohydrates. On the basis of their behavior on hydrolysis, they have been broadly divided into following three groups. First one is monosaccharides, a carbohydrate that cannot be hydrolyzed further to give simpler unit of polyhydroxyaldehyde or ketone is called a monosaccharide. In very simple way we can say these cannot be hydrolyzed. Some common examples are like glucose, fructose, ribose, etc. Oligosaccharide, carbohydrates that yield 2 to 10 monosaccharide units on hydrolysis are called oligosaccharides. Oligosaccharides are further classified as disaccharides, trisaccharides, tetrasaccharides depending upon the number of monosaccharides they provide on hydrolysis. For example, disaccharides are sucrose. Okay, when sucrose is hydrolyzed, it gives 1 unit of glucose and 1 unit of fructose. The same way, when maltose, it is also the disaccharide. When it is hydrolyzed, it will produce 2 molecules of glucose. Okay. Now, next one is polysaccharides. Poly means many. Carbohydrates which yield a large number of monosaccharide units on hydrolysis are called polysaccharides. Some common examples are starch, cellulose, glycogen, gums, etc. Now, there is another classification. On the basis of taste, they are divided into two groups. First one is sugars, carbohydrates which are sweet in taste. For example, glucose, fructose, sucrose, lactose. These are classified as sugars. Another is non-sugars, carbohydrates which are not sweet in taste. For example, all polysaccharides such as starch, cellulose, glycogen, gums, etc. are classified as non-sugars. There is one more criteria to classify these carbohydrates on the basis of reducing property. They are divided into two groups, reducing sugars and non-reducing sugars. Now what are reducing sugars? All those carbohydrates which reduce Fehling solution and Tollens reagent, okay, are referred to as reducing sugars. All monosaccharides, whether aldose means containing aldehyde group, or ketose means containing ketonic group, are reducing sugars. Okay. Disaccharides that have free aldehydic or ketonic group, for example, maltose and lactose, are reducing sugars. Non-reducing sugar, which cannot reduce Fehling solution and Tollens reagent, for example, sucrose, is a non-reducing sugar. Is it clear? Now, what is this glycosidic linkage? The two monosaccharides are joined together by an oxide linkage formed by the loss of a water molecule. That linkage is known as glycosidic linkage. And this linkage between two monosaccharide units through oxygen atom is called glycosidic linkage. If reducing group, that is aldehyde or ketones, are involved in glycosidic bond formation, carbohydrate is a non-reducing sugar. We already discussed, see the structure of this sucrose. Sucrose is non-reducing sugar. How can we explain? Actually, in this sucrose, it is made up of 1 unit of glucose and 1 unit of fructose. And this bond is a glycosidic linkage. And this bond involves this aldehyde group of glucose and ketonic group of fructose. That's why aldehydes and fructose of, we can say aldehyde group and ketonic group of glucose and fructose involved in the glycosidic linkage. That's why it is a non-reducing sugar. On the other hand, this is maltose. This is made up of 2 units of glucose. Okay, and in this first carbon atom of 1 unit of glucose containing aldehyde group, and this is not involved in the glycosidic linkage. That's why it is a reducing sugar. Okay. Now, monosaccharides are further classified on the basis of number of carbon atoms and the functional group present in them. If monosaccharide contains an aldehyde group, it is known as aldose. And if it contains a keto group, it is known as ketose. And on the number of carbon atoms, we can classify, like if number of carbon atoms are 3, it is known as triose. Okay, if this triose may be aldotriose if contain the aldehyde group, or maybe ketotriose contain the ketonic group. In the same way, number of carbon atoms are 4, tetrose. It may be aldotetrose or ketotetrose. Number of carbon atoms are 5, then this is pentose, aldopentose and ketopentose. If number of carbon atoms are 6, this is hexose, aldohexose or ketohexose. Number of carbon atoms are 7, this is heftose. If contain aldehyde group, then this is aldoheptose. If contain ketone, then this is known as ketoheptose. And most common among them is hexose. Okay, glucose is the example of hexose, and it contains the aldehyde group. That's why this is aldohexose. And fructose, this again contains the 6 carbon atom and ketonic group. That's why this is ketohexose. This is all about the classification of carbohydrates. Thank you. Subscribe my channel to get the next videos from this chapter.